All right, let's get started. Welcome back to our weekly freshman engineering seminar. By now, I think everybody's sort of gotten into the swing of things in terms of our schedule. So you all know the drill. Every week, I'm going to post a quiz on Blackboard sometime later today once I've gone through all the attendance and whatnot. And then the quiz will close next Friday at 11 a.m. So just make sure you complete that on time. In terms of attendance, I'm still going to go ahead and use the sign-in sheets. Our lab tech's going to be here in about 15 minutes or so. So just sign out or sign the attendance sheet on your way out, and we'll collect that at the end. I did want to bring up an event going on within our college. The 2018 Marshall Safety Conference is going to be on Thursday, September 28th, and it's an all-day event. It's taking place at St. Mary's Conference Center in Huntington. And student registration is free, so it's free for you to attend. If you're interested in checking it out, the only thing that they ask is they do want you to register. It just helps them keep a head count and whatnot. But there's probably going to be some pretty interesting stuff there, so it's definitely worth checking out. Sound good? Any questions? All right. So we're going to get back into our regular mode. I've got a main speaker, which I'll introduce here in a little bit, but we're going to start off with our faculty introduction. With us this week is Dr. Sukjun Na. He's a faculty in civil engineering, and he's actually a new faculty, just started here this semester. So I'm going to give the floor over to him. So everybody, let's give a round of applause for Dr. Na.
All right, so you all are freshmen, right? Oh, fresh smell. So my name is Sukjun Na. I'm a new faculty. Possibly I'm brand new faculty, still in a box and shiny. So you can call me either Dr. Na or Professor Na. I'm a professor of civil engineering. My specialization is in geotechnical engineering, which means I'm dealing with soils, so I always have dirty hands on my clay on my hands. So my office is 1215, and my email address is probably the simplest email address in Marshall. NAS, that's it. So if you have any questions, then just try to contact me through this email, right? Currently, I'm teaching civil engineering materials and foundation engineering. So probably your next or third semester, no, next or third year, we're going to see again if you take my courses. All right, today, oh, by the way, I'm originated from South Korea. So that means I'm not your enemy. I'm not from North Korea. So I'm your friend. Please be kind to me, okay? I'm your friend. So let me talk about sustainability in engineering materials. So how many of you have heard about the term sustainability? So many. So buddy, what is the sustainability? It's hard to explain, right? But you know that. Sustainability is a term people have a hard time wrapping their minds around. Is it correct? I feel it. I feel it's sustainability. But it's hard to describe what the sustainability is. In fact, when I was in graduate school, my research project is part of sustainability, part of sustainable engineering. So I've been working on my project for 4 years. So someday, my colleague asked me about my research project. Hey, June. My name is June. So, hey, June, what is your PhD project? So I told him, oh, my project is part of sustainability. I'm working on the failure analysis of recycled polymers to improve our sustainability. Then my colleague says, oh, that sounds cool. So what is the sustainability? Then I just stopped. Even though I've been working on my project for 4 years, I could not explain what sustainability is. I feel that. I know the sustainability is somewhere there, but I couldn't describe it or define what sustainability is. So I Googled it, and this is the long definition of sustainability. Can you read this for us?
Everything that we need for our survival and well-being depends either directly or indirectly on our natural environment. Sustainability creates or maintains the conditions under which humans and nature can exist in productive harmony that permit fulfilling the social, economic, and other requirements to present and
Future generation. Yeah. So I highlighted some keyword. I'm not sure whether you can see the red colors, but nature, harmony, humans, social, economic, and future generation. Those are keywords of sustainability. But I'm a lazy person, so I don't like this long definition. So simply, sustainability is meeting the needs of the present without compromising the ability of a future generation to meet their needs. What does that mean? Let's say my generation. No, we have very limited amount of resources, right? For example, fossil fuels. We have very limited amount of them. What if my generation or Dr. Michael's generation, yeah, we are same generation, use up all the resources, and we are going to give you nothing about it. Then probably you're going back to a cave, right? No electricity, you're living in darkness, no Snapchat, no Instagram, no Facebook, no computer. Are you happy? Are you happy with that? Yes, well, maybe, yeah. We have too many social media currently, so we need to reduce them. But that's what's going to happen. So we always think about our next generation, like you. So there are three critical areas in sustainability: environment, economy, and society. And they are keep arguing each other. For example, environmentalists, tree huggers always say that our environmental first. No matter how much we spend our money, we have to keep our environment clean and save Earth, right? Economists, are you kidding me? We are living in capitalist country. Money is first. Can you live without money? Humanist, calm down, guys. We are human beings. Nothing's more important than us. So they are keep arguing each other, right? Then sustainability comes up. Hey guys, we can satisfy all your requirements by overlapping their requirement here. So that is the purpose or role of sustainability. Resulting in we can deliver our clean earth or resources to your generation, our next generation. That is a sustainability. Make sense? So again, what's the sustainability?
It's preserving
Yep.
the condition
Right?
for future generations.
Yep. So you learned. So now you can describe what sustainability is, right? I hope you take my class. You're a smart guy. All right, so to achieve sustainability, what engineers do? We create renewable or called clean energy, something like wind turbine. We produce clean energy. Or we utilize solar energy. And also we use the tidal energy plant. Those are the clean and renewable energy systems. Also, in terms of materials, we recycled plastics. So have you seen the recycled trash cans out there? Yeah, please put polymers only. In fact, we use huge amount of plastics in civil engineering field. So for example, geosynthetics, geomembranes in a landfill, geogrid to build beautiful standalone retaining walls, and geotextiles. So this is the geomembrane in a landfill. Geomembrane prevent leachate from the waste. And geogrid, you probably have seen these beautiful retaining walls. So inside the retaining walls, we applied geogrid, which is made of plastics. Also, we produce plastic pipe. The advantages of plastic pipes over the conventional pipe materials, which is concrete or steel, it is cheaper. Plastic is cheaper than concrete or steel. Also, it has very lightweight and very flexible. So many conventional pipes are replaced with plastic pipes. Make sense? But there is also disadvantages of plastics. Where does plastic come from? What is the origin of plastics? Fossil fuels, oils. So we have to consume oils to produce plastics. That means that is not a sustainable material. Am I correct? Also, it is not well degraded. So it remains in our environment for years, up to million years. Then, how do we improve the sustainability of plastics? Pleasure. So my research starts from this point. I'm working on plastic materials, and I want to improve the use of recycled plastics in engineering applications. So in fact, we collect the used plastics and then cut them into pieces and then reprocess, and we reproduce recycled plastic pipe. So we utilized recycled materials in engineering field, actually. But the problem is recycled plastic has very inferior properties comparing to the pristine plastics. It has low strength, and once you reprocess the plastic materials, it becomes very brittle. Do you know the term brittle? Yep, it becomes very brittle, which is the opposite to the ductile. So that means it is easy to fracture. So we have to solve these issues for the use of recycled material in engineering applications. So this is my current research project, my current research topics. So I'm working on the failure analysis of recycled plastics for engineering applications. Does it make sense? Yeah. And I want to develop a new class of materials blended with recycled plastics. For example, polymer nanoclay composite. We add some nanoclay with the polymer materials, then we improve its fracture properties. Failure analysis of materials manufactured by 3D printing. Recently, I'm very interested in 3D printing techniques. So I want to utilize 3D printings for the manufacturing of product in geotechnical engineering as well. So I want to develop a small-scale modeling of geogrid using 3D printing and then correlate them with a large-scale test. And then soil-geogrid interactions. So those are my current research interests. So this is all I have today. So do you have any questions? Yes.
What is non-clay?
Nanoclay?
Yeah.
You know clay,
Yes.
right? I recommend you to take my geotechnical engineering class. The thing is, clay particle is really, really tiny, and you are not able to see. It feels like dust. But if you see the clay particles using microscope, electrical microscope, it has a layered structure. And each layer is bonded together. If you just put this clay in a polymer matrix, they have chunk of clay inside the polymer, which is a defect. So we want to separate each layer. The thickness of layer is about 1 nanometer. Pretty thin. So we modified the surface of clay particles, then it becomes separate. And then it can be blended with polymers. This process, the clay particles obtained from this process is called nanoclay because it has nano size.
Any other questions? Well, first off, let's give Dr. Na a round of applause.
Thank you.
All right. Thank you again. Thank you. One of the things that you will learn in this class is that civil engineering is a very, very broad field. Dr. Na is a geotechnical engineer. As you might remember, I'm a structural engineer. And our main speaker today is with the West Virginia Division of Highways, and he's a hydraulics engineer and hydrology engineer. His name is Doug Kirk. He's going to be talking to you about some of the things and projects that they work on at the DOH. As well as maybe some potential opportunities for you all. So everybody, let's give a warm round of applause for Mr. Cook. Thank you. Here's that. I'll get you set up.
So I could have let Dr. Na just keep talking. That's fascinating. You know, sustainability. I've got a note on my desk to figure out whether recycled pipe is okay, because we're switching from metal pipe to plastic pipe, because what we figured out is that those metal pipe salesmen that said metal pipe lasts 75 years, they weren't talking about in the real environment. It really lasts 20. So we're using plastic. And so plastic pipe has become real competitive, you know, from an economic side. And so some of these guys like, you know, we can make this cheaper if we use recycled pipe. And then the guys that say, no, we need to use virgin polymers are telling me, well, that recycled is crap. It'll only last 5 minutes in the environment. So we got to figure out, you know, if this recycled pipe is really going to work. One other thing, before I let you go back to your busy time, what part of Korea are you from?
Seoul.
Seoul, the big city. Okay. So I was stationed at Osan, and you'll see a picture here in a minute. Aircraft hangar that I helped build. But yeah, it was like 14 million people, and they all just got cars last year, and their parents didn't teach them to drive. That's the way it was when I got there. So if you think about the things that your parents taught you about driving, you know, be careful, yield the right of way, pay attention to none of that applied yet. So I don't know how they didn't have just crash after crash after crash. And you know, I knew people that ran over pedestrians because they just stepped out between two cars and they never thought to look. And so I suppose that driving in Seoul is probably a lot better than it used to be, right?
I wish.
Now there's probably 18 million people.
Recently we have
10
10 million.
million, okay. So maybe 14 was like the metro area or something.
Metro.
Okay.
Metro.
But it was a big modern city. The thing about, you know, you talk about Korea up until my lifetime really was a third world country. Now it's a thriving metropolis, but when you get outside the city, I was there several years ago, and it was still pretty backwards at that point. We went camping up near Wonju, and there was no electricity, and you could see the Milky Way and really understand why they call it the Milky Way, because when you looked at it, there was more light than darkness in the sky. And I know you probably can't, you know, living in the city, you can't comprehend that, but when you get out to where there's no electricity, look at the Milky Way, look at the sky and say, wow, there are more stars than we can count. So anyway, thanks for sticking around for a minute. All right, so my name is Doug Kirk. I'm from the Highway Department, and talk to you about things at highways. So can you guys see the pictures okay? Does that show up well enough? Is lighting all right? Okay. So I'm going to get where I can see and everything. So I'm glad to be here at Marshall University, and I was on vacation with my wife, and we happened to run into your mascot there, Marco, in South Dakota, so we got a picture with him. So that was fun. So why is Marshall such a great school? And I want to say that it's because you have tenacious instructors. And so you probably recognize Dr. Michelson. These other guys, as freshmen, you probably haven't had yet. Dr. Waite there in the middle is the hydraulics professor. And as you can see from the picture, he's running the Leadville 100-mile trail run. Now, how many of you guys have run 100 miles nonstop? I haven't either. I tried 30 last year, and I had to keep stopping and resting. But so that tells you how tough this guy is. So when you get in his class, he's going to expect the same out of you guys. And Dr. Zitar over there on the far right is equally tough. And so you guys already know that you're going to be challenged here. And don't be afraid of that. Know that that's the only way you get better, is that you are challenged. And you wouldn't be here, you wouldn't be in engineering if you weren't up to that. So I just want to say that to encourage you to dig in, and when you get scared of a test or you get afraid of your project's not going to be done, just go at it. Just be tenacious, and you'll get through it. So civil engineers go everywhere. We go a lot of places and do a lot of things. So on the upper left there, that is, I think that was probably a TR-1, but it's a version of the U-2 spy plane. It flies 70,000 feet in the air and keeps an eye on the bad guys. And so the hangar, I didn't fly the plane, but I helped build the hangar behind it. And then over on the right, this is North Carolina. This bridge was built after I left, but I surveyed this hillside. We had to cut down rhododendron with chainsaws and machetes to be able to see the ground, because the LiDAR didn't do any good, or the aerophotogrammetry didn't do any good to see the ground. Mount Fuji, I got to go there, and this is where Knob Noster, how many have heard of Knob Noster, Missouri? Same as have run 100 miles. So this is a little town near Whiteman Air Force Base, and that's near where I ended up going to college at University of Missouri at Kansas City. So a lot of travels, a lot of opportunities to go different places. As an engineer, there's always something to do. There's always something broke. There's always something that needs fixed or improved. And as civils, you can see here in this picture a lot of things that we work on, from the bridges, both highways and railroads, the wastewater treatment plant there in the bottom, or maybe that's the water treatment. Let's see, this is on the yellow. That better be the water treatment plant, because that's where my drinking water comes from. So this is the water treatment plant. Ball fields, when you guys get older and have kids, and your kids play ball, they're going to look at you and go, oh, you're an engineer. You can lay out the ball field. You know how to make the field square and find the corners and all that stuff. So, and buildings, of course, structures. Most civil engineering students think they want to be structural engineers. That's what I thought when I was in college. And my first job was geotechnical and environmental. And then I ended up in other things as well. So you get to have fun with math and science. How many of you, your favorite class was either math or science? Okay, how many English? How many said English or social studies? Okay, so this is engineers. So you get to have fun with all that stuff. So rewarding career choices. There's a lot of different things you can do. We've already heard a little bit about geotech, and you say he has dirty hands. We're talking about plastic bottles. You know, you didn't tell us about proctor tests or drive tubes or anything like that. So, you know, there's diversity even within what you think is a narrow field, and you can work just about anywhere you like, whether it's close to home. How many of you guys are from outside of West Virginia? Oh, a good number. That's great. That is encouraging. So if you want to work, if you want to stay here in the Huntington area or the Charleston area, there'll be jobs here. If you want to go back to where you came from, there'll be jobs there for you. And the pay is, I say good, it's not going to be like lawyers or doctors or something like that. But the other thing is you can go to work after 4 years. And that's a good thing. I would encourage you to continue on once you figure out what you really want to do and what you want to specialize in, to try to seek opportunities to go to grad school. But you can't go to work after 4 years only. So right away, your technical skills are going to be what's going to be important. That's what's going to get you a job, is your technical knowledge and your problem-solving skills that you can develop here in engineering school. But some of you are going to become the boss one of these days, and you're going to tell other engineers what to do. You're not going to be so hands-on and know exactly what they're doing. But it's kind of a progression people go through as they get older. Some of them stay technical and they retire with their calculator in their hand, or whatever device they happen to have at the time. And some of them work completely outside engineering. I knew people that went to engineering school and immediately became salesmen, if you can imagine that. These are the talkers in your class that become salesmen right away. And one of the graduates here from Marshall went to the mission field. He was involved in the crew organization here, and he spent the last 5 years in the Dominican Republic. Some of our projects are really amazing. This is East Huntington Bridge and the New River Gorge Bridge, two of our more spectacular bridges. If you get a chance to, of course, the Huntington Bridge, you guys have all seen this because it's just down the road. The New River Gorge, it's pretty cool to see. The view is better from the river. I guess just because I'd rather be in the river than on the road. Some are kind of interesting. So I know you guys are freshmen, but we're going to ask you a hard question. Do you see the end of the beams right here? What's holding up the ends of those beams? Structures in the wall. Okay, that's what you would expect. Now we can see. Nobody go to sleep, especially me. So this abutment here has been here for like 100 years, and about 40 years ago, the bridge that it supported fell in the river. So they put this temporary bridge in here 40 years ago, and you see the beam ends right there, and then you got this little channel that just kind of makes a ceremonial connection to the abutment. The abutment really doesn't hold up the bridge here. These bents in the river, these are called bents, they're like piers. That's what's really holding up this bridge. So I didn't see this until after I'd driven across it. If I saw it first, I probably wouldn't have driven over it. But that's kind of not something you would design. Your engineering professors would tell you, what's the factor of safety on this? This is terrible. So here's another good one. I'm standing upstream looking downstream. I'm standing, when I took this picture, in a 10 by 10 box culvert, because that's how big the structure we need for the water from the creek to get into. This pipe that you can just barely see the edge of is a 6-foot pipe. And now keep in mind we're looking downstream. So we need a 10 by 10, and then we need a 6-foot diameter pipe. You smart guys can go ahead and calculate the cross-section area of each of those. The first one's 100. The other two are a little smaller. So then it goes into a 48-inch pipe. So it's like a funnel. And the problem was the plans showed an actual funnel from the 6-foot pipe to the 4-foot pipe. But the builder decided it was cheaper and he could make more money if he left out the funnel part and just kind of stuck the two pipes together. But what he forgot to do was educate the water to tell it, hey, when you get to the end of the 6-foot pipe, instead of jumping through this crack in the pipe here, you need to go on down the pipe. So these were some interesting projects. We have since fixed the pipe. We put a new pipe in there. And this bridge is on its way to being built. So you can feel safe if you go to, this is on the Buchanan River. I can't remember where it is, but you have to go there on purpose. It's somewhere near Helvetia. So that should tell you it's out in the middle of nowhere. And this is at Jaeger. How many people have been to Jaeger? Spelled with an I. Several of you. Outstanding. So I forget the name of the business, but you can look over the hill toward the railroad and see the new black pipe. It's plastic. It's the solid wall plastic. And it's above the ground. So you'll see these projects. All right. Working inside and outside. I have an office, but I'm outside quite a bit. I was out a couple days this week, yesterday, looking at a sinkhole. And we were trying to figure out how to stop the flow of water into the sinkhole. And It was kind of a challenge until we walked up the creek and found the broken sewer pipe, and that fixed it. So the Division of Highways, we have about 38,000 miles of road and more coming online this year. 7,000 bridges, that's a lot of bridges. And if you think about it, if a bridge is going to last 70 years, how many bridges do we need to replace every year just to keep up? 7,000 divided by 70 is what? 100, very good. Will that be on the quiz? I don't know. That's too easy. So 100 bridges a year, so there's a lot of work to do. Central office is in Charleston, and that includes planning, engineering, traffic, right-of-way, contract administration, materials, maintenance, and the bureaucracy divisions, as I'll call them. We also have 10 district offices, so if you want to be away from the city and you want to work on projects that are more expedient, got to get it done this week. And we don't have 2 years to develop the plans, and it's not going to cost $4 billion. District is a fun place to work, so we have offices in all the cities that you see listed there. Burlington. How many know where Burlington is? All right, Eastern Panhandle people. Very good. Yeah, I was going there, and I said, okay, I know when I come down the hill, I'll see it. And then I started back up the hill. I was like, I missed it. It was that small. All right, so my highway experience, I spent a couple years in roadway design and learned about laying out the geometry, you know, how to get over the hill and through the woods and around the bend and across the river. Project management experience, that was very valuable. And then I spent about 10 months in consultant services, and this job was helping hire consultants, you know, private firms to do the same kind of work I was doing. I didn't like that very much. I wanted to do the work myself instead of just meeting with them. So I didn't last very long in consultant services. 3 years in structure design, that was a lot of fun, but when I realized the longest bridge I designed wasn't even long enough to span the width of a lot of bridges, I thought, you know, I'm never going to make a difference in bridge design. So I switched to hydraulics and spent the last 17 years there. And that's a lot of fun. You get to play in the creek, and deal with bridge hydraulics and culverts and storm drains. So I've worked in all 55 counties, and you can see the map here. And this is the Blennerhassett Bridge, U.S. Route 50 over the Ohio River in Blennerhassett Island at Parkersburg. I got to help on the hydraulics of that project. From bike paths to interstate highways, we've worked on everything. Some of us work in the office, and some work in the field. If you work in construction, you'll be out there supervising and keeping an eye on the contractors, making sure they build what we drew in the office and make sure that it is going to be sustainable, it's going to last for the next generation. It's not just going to be a way to spend money for our generation and have jobs. So functional areas, I think this is, I don't know, Dr. Na, is this roundabout in Seoul? Is that in Seoul?
No.
So the interesting thing here, how many have driven in a roundabout? Okay, so who has the right of way in a roundabout? Is it the people coming into the roundabout or the people trying to get out? People trying to get out. Because if you don't do it that way, look what happens. In this case, these buses have the right of way to get in front of these cars that can't get out. So they get blocked by these buses who are blocked by these buses who are blocked, you know. So just something to remember if you end up in traffic engineering. Yes, ma'am.
Why do y'all create
Roundabouts.
roundabouts?
Okay, I wish your new transportation faculty was here, or my brother was here. He's a traffic engineer. So personal roundabout is like somewhere between a four-way stop and a traffic signal. And it keeps the traffic flowing. You always are keeping going. You know, when you come to a stop sign, you got to stop. And he stops, and he stops, and they stop. Everybody stops. And so the level of service dies very quickly on stop signs because everyone stops. You know, you stop and wait for the car ahead of you. And so it really slows down traffic. Traffic signals, lights are very expensive. And if you have a lot of different turning movements, people turning right, people turning left, people going straight, you've got to have 8 different cycles for this. So everybody gets their turn. And so that clogs up too. But with the roundabout, you're always moving. It's always fluid. You have to slow down, and you have to pay attention. But it is a better way to do it fluid-wise. Problem we have in West Virginia is they take a lot of space, a lot of land. So that's tough. We tried to put one in Glenville. If you've ever been to Glenville, you know that the whole valley is about as wide as this room. And so it's hard to stick a roundabout in there. So that's why we do roundabouts. But this is just a list of some of the disciplines that you can work in. Design, construction, materials, maintenance. We have people that their whole job is to test soil every day. And some keep track of our maintenance records, and others do planning where they're just trying to dream and scheme. Where do we need the next road? You know, that's their job. All right, so here's kind of the engineering process, and this I stole from the traffic engineers, and this is like developing a signal system or something like that. So we start out on the left, we have a problem. We want to try to figure out how to solve that problem. So they have this V-shaped process. Others use more of a circular process. So we know we have a problem. Let's figure out, let's just imagine what the answer might be. Then we have to plan. How can we really do this? Do we have enough money? Do we have enough resources? All right, let's figure out the details of it. So that's the creative part. And then step 5 is actually building it and improving it. And sometimes you have opportunities to go round and round through this cycle on just one project where, okay, we're improving. Now let's figure out how do we make that better. Now, like our roads, we're going to build it. We're going to say, you know, that road's not big enough. Okay, what do we need to do? Do we need to add lanes? Do we need to put a roundabout in? All kind of questions like that. And it goes through the whole process over and over. But it all starts with a problem and someone figuring out how to solve it. So planning, they produce this beautiful map for us, and they also deal with metropolitan organizations like Huntington, you know, has an MPO, and they try to solve the problems of the city. And so that's kind of the focus of planning, is more long range, more sustainability, more looking ahead to the future. In design, this is just a screenshot of our CAD program that we use, and we've got a road to nowhere going up through Boone County that we're designing here. And you can see by the light green contour lines how steep it is and how close together the contour lines are. Just the menus. Do you guys teach AutoCAD or MicroStation here? MicroStation. So you'll see this. It'll probably look different by the time you get to it because they constantly change it. Job security, you know. This is HECRAS. This is the river analysis system that we use. If you end up working in my unit or in the Corps of Engineers, you'll see this. And it's a program that we use to model the river, figure out how deep the water is and how fast it's going, and whether or not the bridge is going to wash out. So construction, once we take our plans, we draw, and they build the road. Hopefully this fancy little curve wouldn't happen in Huntington, but it happened somewhere. So as I mentioned, you can work in the central office or the district. This view of the Capitol, that was my view from my office at the Capitol until they moved us. And this down here is Burlington. So when you get to Burlington, you'll know what it looks like if you have trouble finding it otherwise. So they moved us from the Capitol complex down the street to Smith Street. We're in a little metal building that was supposed to be torn down to be a parking lot, but we're still in there. Ballpark is just across the street, so I can go look at the green grass in the spring. It greens up faster than mine, so in February when I say, man, this winter is killing me, I can go over here, and it's kind of encouraging. So to start your career at the Highway Department, the first step is our co-op program. This is a way that you guys, even this coming summer, can be introduced to working for the Highway Department. And your professors will have information for you through the ACEC and your career encouragement people with the Career Services Office, right?
You'll get info probably on this either from Career Services or from Lee McDonald. So if you all been getting emails from Lee, she's our admin in the engineering division. Don't throw them into the junk folder because it's probably something like this, showing you how to apply for positions like this.
So this will give you an opportunity to work in any of the fields that I talked about before. Usually as freshmen, you'll work in construction, which is very good. You'll need boots, and they'll give you a hard hat, and you'll be out there watching them build something, and you'll see all the pitfalls, and you'll see them cussing us in the design office, saying these people don't know what they're doing. And so when you get to the design office, you'll know what mistakes not to make. But the pay is not bad. It's better than McDonald's. You'll start out about $11 an hour your first year, and then it progresses from there as you get closer to graduation. But fill out that application, send it in. We'll find you something to do. and be aggressive when you're a co-op to get work. You really have to work at it. Sometimes your boss doesn't want to invest time in you, but do your best to encourage him to do that. Another option is the scholarship. After your sophomore year, once we believe you're really going to make it through this, once you've got through differential equations and physics 2, and what's the weed out course here? What do you use?
Well, you got statics, mechanics, materials, all that stuff.
Oh, statics is easy. Sorry.
Everything going up equals
Mechanics,
everything down, right?
yeah, mechanics and materials. Okay, so that could be your weed out course. But once you got through those classes, then we can give you some money to help you get through college. And some of you guys probably have the Promise Scholarship and such like that. So this is pretty good. And I just got an email today from our human resources people, and they say, hey, we got this student for you. He's going to graduate in December, and we're obligated to give him a job because he's a scholarship student. I'll just leave it at that. So if you serve as a scholarship student and you don't make your boss too mad during the summer, we'll give you a job when you graduate. So starting your career, once you are in your last semester or maybe even just a little bit before, go ahead and apply online. You guys can just Google West Virginia Transportation, Highway Engineer Trainee jobs, Division of Personnel, anything like that, it'll get you there. The job you're looking for is Highway Engineer Trainee. So starting pay is about $47,000, and I don't know if you guys have started looking yet, but that's on the low side, I'll just be honest with you. But benefits are good, work hours are good, opportunities to continue to learn is really good, so I think it's a good place to start.
Also, a pretty clear path towards licensure.
Right, and let me back up just so there's more light. Licensure is critical. I'm sure these guys will tell you that, and we'll talk more about it later. That's your goal, is to be a professional engineer. Getting out of college, you'll be disappointed when you sign your first report right after college, and it doesn't say engineer. It says something like engineering technician or engineering assistant or something that you might think is like, I'm an engineer, for crying out loud. Until you're a professional engineer, you're officially not. So working toward being a professional engineer is key. Do well in your classes, take your tests when you're supposed to, and keep up your continuing education work.
For you civils, we do FE exam review at your senior year.
All right, so get more out of college. Oh, that's perfect. So by putting more in, do your homework, especially if it won't be collected for a grade. Coming out of high school, probably your high school teachers relied heavily on your homework for your grades, and if you struggle on tests, you could make it up on the homework. And you'll come here and they'll go, no, I'm not going to collect that. And you're like, oh, well, heck, I don't have to do it. No, that's all the more reason to do it because it's a trap. Make sure you do the homework because that's the only way you're going to practice enough to be able to succeed on the test. It has to be like muscle memory. You've got to just be able to look at this problem and go, oh, I know this, and crank through it. Write class notes by hand. Recent studies, we got this technology now, right? So you want to type it on your iPad or on your phone or record it or whatever. If you write it out with your pen and your paper, you'll remember it better, so try that. Develop your writing and speaking skills. When you get in group projects later on, you're going to be busy and you're going to say, you know what, if I have Joe write the report and Steve do the presentation, I'll have more time to work on this other class. Don't do that. Give the report, write the report, and give the presentation. Those are opportunities for growth, and for a lot of us engineers, public speaking is not our natural bent. It's a learned skill. We're not very good at it, we think, but we can learn how to do it. Build a steel bridge and paddle the concrete canoe. These are, again, extra things that you might not think are valuable, but they are. It's a good opportunity for project management. Problem solving, you're going to have to deal with a limited budget and time constraints, and so that'll be good for you. Have the college fun. You're here at Marshall. This is a big college. This is a good place to be. There's a lot of fun to be had. There's other students across the street that you want to get to know. Football stadium, so go to the ball games and all. Have the fun. But make sure you really focus on your studies so you don't have to try again later like some people I know. Take the FE as soon as you can, the Fundamentals of Engineering exam. It's all about what you learned in college. So the further you get from college, the harder that test is going to be. If you take it as soon as they'll let you, then you'll just go, oh, that was a lost Saturday, but it wasn't hard. But if you wait, 10, 12, I've known guys that take it 30 years after college, and it's very hard. So take it as soon as you can. All right, so does anybody have any questions? Yes, sir.
In general, how long do people who work in engineering management work as a technician before they move on to management?
Well, I'm not saying you really work as a technician. I mean, are you talking about with an engineering degree?
Yeah.
So you're going to be doing design work. You're going to be doing the calculations. You're going to be, doing the layout and all that. The technician work now, because with computer integration, is pretty well integrated into the engineering work. But I'd say it varies from person to person. My job is kind of a mix of management and technical work. And so, I don't know, I'd say on average, in 3 or 4 years, you're going to start doing some management work. Probably most people stay technical for 15 or 20 years, and some their entire career. It just kind of depends on what job you end up in and what your natural bent is, and you may not know the answer to that yet.
There can also be a big difference between whether or not you go government or go private sector, because there can be differences there as well.
Right, and government, you're going to end up in, there are opportunities for management will come to you sooner than in the private sector, and opportunities to stay very technical will last longer in the private sector for the most part. Yes, sir.
All the way back to the start,
Uh-huh.
what causes those pipes to have a shorter lifespan than plastic?
Oh, okay. So those are steel pipes, so it's just steel, and they put zinc or aluminum on the outside of it to coat it. And those things don't rust. They don't, turn orange and disappear like the steel does. So what we found is the combination of abrasion and corrosion, acid bind drainage, low pH water washing through those pipes, carrying sand and gravel will grind the zinc and aluminum coating off of those pipes. And then the acidic water just rusts them out. If you throw a nail in a Coke bottle, see what happens, see how long that lasts. So it's rust and corrosion, or rust, which is corrosion, and abrasion from the sediment load coming through the pipe. Yes?
Was the New River Gorge Bridge, was it kind of designed to have a protective coating of rust around it?
Okay, I'm going to teach you a new word.
Okay, I said protective as a general.
No, that's a very good question. So I'm going to teach you a new word, patina. It's not rust, it's patina. It was called Core 10 steel. You might hear weathering steel. These bridges that turn brown before they're even finished, it's an oxidation, but it's not like rust that just makes a soft flaky layer that just crumbles off and exposes more steel to rust and fall off continually until it's all gone. The patina sets up as a harder layer, and it makes it a protective coating. It has to do with the copper content of the steel.
You can always spot a weathering bridge, like this gentleman's t-shirt. If you ever see a steel girder that looks like that, that's usually a weathering bridge when it's got that sort of like maroon brownish color. It's usually an instant giveaway.
Yeah, the Lower Buffalo Bridge over the Kanawha River is weathering steel. And we've used weathering steel for a lot of bridges because we don't like to paint bridges. It's not fun. It's expensive and challenging. So we try to use this weathering steel whenever we can. We found that it's effective as long as you have wet, dry cycles. It rains and then the sun shines. If you have places where the sun never shines and it stays wet all the time, then it doesn't work so well. So you got to kind of choose where you want it to be. Bridges that are likely to be inundated by floods, that's not a good choice for weathering steel. But yeah, weathering steel, and it's not rust, it's patina. So when when friends and family start telling you, look at that rusted bridge, it's like, no, that's not rusted, that's weathering steel, and it has a patina. That's a protective coating that develops on it.
Is that why you can't use it on the pipe that you were talking about?
Yeah, it wouldn't work for pipes.
Okay.
Yeah, it wouldn't work for pipes. or you can pay it back. Yeah, it is an option. You can pay it back. And some people have paid it back. Some people have, their company has paid it back. We've had companies write us a check to pay back scholarship of students.
If a company really wants you, and that's the barrier, they might say, "What's no big deal? Here you go."
Yeah. Well, I guess you could use it as a loan. But it's not intended to be that way. It's intended to be a scholarship. We're going to help you get through college, and then we're going to guarantee you a job when you come out, and you're going to work for us for the number of years, I forget it, typically 4 years that you'll work for us. And I've got one guy that works for me now that he was on scholarship. He came to work for us. He worked for us for a year and a half and said, you know what, grass looks pretty green over there. About a year later, he called me up and said, hey, do you want to have lunch? So he came back to us, and so he was already paying back the scholarship, and he was like on a payment plan. And so then we stopped those payments when he came back to work for us. So,
Any other quick questions, Mr. Kirk?
yes, sir.
So, if you have to pay back the scholarship, like any work for the company, does it like come out of your check, or would you be getting full checks whenever?
We're not going to garnish your wages for it, no. No, this is not like child support. Sorry. Yes, sir. Or you're just stretching? He's stretching. Okay.
Any other questions? All right, two things. First off, let's give Mr. Kirk a round of applause. Second, don't forget, attendance sheets are going to be in back. Make sure you sign in before you leave. We'll see you next week. Let me stop this recording quick.